A very good morning to my Inchihata. My name is Vaidishwari Tiago. My metric card number is 09DEM22F1036. Today we want to present about programmable logic controller case study 1. Objective of factory. Separate green and blue items using a vision sensor. Monitor the performance of various process and aspects of machine operation. Input and output of our factory. Input 1.0 at exit, factory reset, factory pause, factory running. We use two machine center, one open, another is busy. Machining center 1 open, machining center 2 open. Machining center 1 is busy, machining center is busy. We use retroelective sensor for 2, 3, 4, 5. After that, we using 2 vision sensor, 3 diffuse sensor. Output entry conveyor, belt conveyor, sorter, 4 sorter belt, turn belt. Belt conveyor 1, we use 2 meter belt conveyor 4. After that, belt conveyor 4 meter, we use 3. Curve roller conveyor 2, roller conveyor 4 meter, we use 2. Roller conveyor 6 meter, we use 1. Emitter for blue color emitter, we use 2. After that, stop blade.
Hi, I'm Mervin Ananalaki Benedict. My number is 09DEM22F1022 and I'm from DEM4B. We're gonna see how many operators must be involved. Number 1, automotive level. Number 2, complexity of sorting process. Number 3, production volume. Next, shift patterns and workload. Lastly, safety and regulatory requirements. Now we see the explanation of it. Number 1, automation level. Highly automated with advanced robotic, computer vision system and automated conveyor system. Number 2, complexity of sorting process. Simplified criteria and smooth process requiring minimal manual intervention. Next, production volume. Moderate volume of item being sorted. Number 4, switched patterns and workload. Station operators 24/7 across multiple shifts. Lastly, safety and regulatory requirements. Compliance with safety regulation requiring minimal addiction personnel of safety monitoring.
Alright, my name is Tiran Raj, Maniwanan, and my metric number is 09DEM21F2005. Okay, now I'm going to present about the step of operation. Okay, the production operation can be stopped at any time, restarted or reset. Okay, point 1, emergency triggers and emergency stop, interrupting the articulated robot and the CNC. Start the station. And for the third point, stops the articulated robot and the CNC to restart, press the start or reset button. And as for the point 4, resets the station. And then 2 stacked lights placed on top of the safeguard provide information about the current status. and for the green light not busy, and for the yellow light busy, and for the red light has an error. Incorrect item detected at entry bay. And finally, the sorting station will have input sensors to detect the presence of items entering the station. Then next, there will be a mechanism for sorting items based on some criteria. The sorting process is controlled by logic programmed into the factory I/O software. Once items are sorted, output actuators are used to move the items to their respective destinations. And then feedback sensors may also be employed to verify that items have been successfully sorted and moved to the correct location. And then in real-world applications, factory I/O can be integrated with programmable logic control (PLCs) to control the sorting process. And then we're going to move on to the PLC programming. Okay, for the PLC programming, we are going to use GraphCAD instead of ladder diagram. And as for step 1, we are going to do nothing on it, and on trans 1, we are going to put input at axis. And for the step 2, we are going to put it on qualifier. All of them are AND and action. First one, emitter 2 exit, emitter 3 emit, and for the third output, belt conveyor 2 meter, and then finally belt conveyor 2 meter. And we are going to move on to the trans 2. As you can see, we are going to put input for 2 for the trans 2, which is a retro reflective sensor 2, and then secondly retro reflective sensor 3. And as for the step 3, we are going to put output qualifier as AND, and the action will be machining center 1 opened, and the second machining center 2 is busy. And as for the third output, machining center 1 is busy, and finally machining center 2 opened. So we're going to move on to the second slide, which is we are going to put trans 3 2 outputs, which is retro reflective sensor 4 and secondly retro reflective sensor 5. And for the step 4, we are going to put 6 of the output, which is qualified we are going to label as, and action output will be belt conveyor 2 meter 1, belt conveyor 2 meter 4, and thirdly belt conveyor 4 meter 3, and fourthly belt conveyor 4 meter 4, and as for the 5, belt conveyor 4 meter 5, and finally belt conveyor 4 meter 2. And network 3 will be input vision sensor 1 and sorter 3 belt. And as for the stop command, we are going to input tag 1, and for the output it will be sorter 3 belt and then sorter 3 turn. Into the next slide, for the ladder diagram in network 4, we are going to put the input in diffuse sensor 3 and then roller conveyor 4 meter 3. And as for the stop command, we are going to put tag 2. And as for the output, it will be 2, which is roller conveyor 4 meter 3 and curve roller conveyor 1 CW. And as for the network 5, it will be roller conveyor 4 meter 3, and we are going to input time tone in the network 5, which is for the 5 seconds, and output will be tag 2. And as for the network 6, it will be we are going to put input 2 inputs, which is diffuse sensor 1 and then entry conveyor, and the stop command will be 2, which is tag 3 and tag 4, and output will be entry conveyor. And as for the network 7, we are going to put input as a sorter 3 belt, and we are going to also apply time tone in this ladder, which is for 5 seconds, and the output will be tag 3. In network 8, we are going to put the input for 2, which is vision sensor 2 and sensor 2 belt. The stop command will be tag 5, and the output will be sensor 2 belt and sensor 2 turn. And as for the next network 9, we are going to insert 2 inputs, which is diffuse sensor 2 and roller conveyor 6 meter 1. And the stop command will be tag 6, and the output will be roller conveyor 6 meter 1. And as for the network 10, we are going to put the input for 1, which is roller conveyor 6 meter 1, and we are also going to apply time tone in this ladder diagram, which is for 5 seconds, and output will be tag 6. 11, we are going to apply input as a roller conveyor for meter 3, and we're also going to apply ladder time tone in it, which is for 5 seconds, and the output will be tag 1. Network 12, we are going to apply one input in it, which is roller conveyor 6 meter 1, and as for the time tone, we are going to apply for 5 seconds, and also the output will be tag 5. And as for the network 13, the last diagram, the last network, the input will be sorted to belt, and we're also going to apply time tone in it, which is 5 seconds, and the output will be tag 4.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Nurul Zarhana Zatasha binti Madasri. Nombor matrik saya 09 DEM22 F1020. So untuk cost estimation projek kami menggunakan 9 jenis komponen atau mesin. Pertama ialah belt conveyor 4 meter, 5, kuantiti adalah 5, dan harga untuk setiap kuantiti adalah RM6,000. Yang kedua ialah belt conveyor 2 meter. Kami menggunakan 4 belt conveyor 2 meter, dan harga untuk setiap belt conveyor 2 meter adalah RM3,000. Seterusnya ialah machining center sebanyak 2 yang berharga RM43,000. Yang keempat ialah vision sensor, kuantiti adalah 2, dan harga untuk setiap unit adalah RM14,000. Seterusnya ialah roller conveyor 4 meter, kuantiti 2, harga untuk setiap unit RM15,000. Roller conveyor 6 meter, 1 unit RM23,000. Curve roller conveyor 2 unit RM14,000. Diffuse sensor sebanyak 3 unit RM125. Dan yang terakhir ialah retro reflective sensor sebanyak 2 unit yang berharga RM800 untuk setiap unit.
Now we move to advantages of automation system. Process optimization to elevate layout, equipments and algorithm system and sorting station in factory I/O. Cost saving. Prototype require waste downtime and manual adjustments are reduced with visual testing. Risk mitigation. Prior and actual implementation identify and resolve problems such as bottlenecks or safety dangers. Education and training, particularly perform for equipment and process management operator training. Next, performance monitoring, measuring throughput, cycle time and error rate in real time using KPIs. Flexibility and scalability. Sorting station may be easily designed and modified to fix a variety of businesses and situations. PLC integration. Using PLC integration, testing sorting station logic and control system smoothly. Visualization and communication. Stakeholders can debate, access and make decisions more easily when information is visualized present. Thank you. That's all from me. Thank you.